In Cycle 3, Lesson 6, sinusoidal applications, we're just going to look at applications of sine and cosine functions. Here's a quick review of some of the things we need to know. Period, length of one cycle. Maximum, obviously the highest point on the function. Minimum, lowest point. Being periodic, a function has to have both a highest point or a lowest point. Logically, we can't have a repeating function if it doesn't get to some maximum and then come down, and then get to some minimum and go up and keep repeating that. The axis of the curve is the middle, halfway, let's just describe it this way, it's halfway between the max and the min, maximum and the minimum points. So we can represent that with a horizontal line. The way being halfway in between, it's really the average of the max and the min. So it's going to be a horizontal line. So it's going to be y equals, and it's going to be the max plus the min divided by 2. Add them together, divide them by 2, that's the average. That'll be halfway in between. The amplitude is the distance from the axis that we just talked about, just figured out above, to the max or the min. So in other words, another way of saying it is it's the distance between the maximum and the minimum divided by 2. We usually let A represent amplitude, and it would be the maximum minus the minimum divided by 2. So those two formulas are very similar. Phase shift is just another phrase for the horizontal shift. So let's see how we can use this, put these things together to solve some problems. A nail located on the circumference of a water wheel is moving as the current pushes the wheel. The height of the nail in terms of time can be modeled by the graph as shown. So let's take a look at the graph here. We've got height on the vertical axis. We've got time on the horizontal axis. We can see that one cycle starts at the maximum, goes down and completes itself in 10 seconds. So the period is 10 seconds. If the maximum's at 3 and the minimum's at -1, then the axis is going to be halfway in between them. So the axis of the curve has got to be here, right? If I wanted to calculate it, I certainly could, since I know the max is at 3 and the minimum's at -1. From our formula just above, we add them together, divide by 2, and that's just another way of seeing where the axis is. It's at y equals 1. What does it represent? It's halfway between the max and min. I don't think there's any better way to say it than that. It's really the middle of the height. What's the amplitude of this function? What does it represent? Again, we have a formula for that. I can get amplitude by doing the maximum minus the minimum and dividing by 2. That double negative changes this into a plus 3 plus 1, so I'll end up with 4 over 2, which equals 2. So the amplitude is 2. I could see that on the graph, pick any maximum or minimum and just measure the distance between these two, and it's obvious that the amplitude is 2 from that as well. That represents, again, the distance. Sorry, I just had a thought, a different way to describe it in terms of this problem. It's a water wheel, so it's the distance from the axle of the wheel. All wheels have axles. To the outside of the curve. So we got this water wheel. Let me draw a picture. That's the best way. So if we're looking at this water wheel from the side, and this nail is on the outside of it, let's say it's here, and it goes around, it's going to go around this wheel, and it's going to go to a maximum height of 3, a minimum height of -1. The distance, the amplitude, is going to end up being the distance from the middle of the wheel to the nail, the maximum or the minimum, right? Well, that's just the radius. So the distance from the axle to the nail, which happens to be on the circumference, so it's the radius of the wheel. So now that I've realized that that's what this question is getting at, let me backtrack for a second and talk about what the equation of the axis is. It is halfway between the max and the min. If the max is up here and the min is down here, halfway in between is the height of the axle, isn't it? That's going to be right here. So it's the center, or another thing we could say is the center of the wheel. There's different ways of wording it. Why don't I say center of the wheel? What's the period of the function? Well, I just showed at the beginning with that highlighted in green, 1 cycle takes 10 seconds to take place. And what does it represent? That's the time for 1 rotation of the wheel. Write the equation for this function. Well, believe it or not, we got all the things we need now, or at least we can find anything that's missing. So if we remember various things that, first of all, are transformations. We can always use transformations to write a function out. So let me just remind you of what a transformation looks like. For a trig function, it's going to be y equals a times sine or cos. It doesn't matter. Take your pick. I could replace this sine with the cos. Same thing. Of k times x minus d plus c. Like I said, it could be cos as well. So my axis of the curve is my c value as far as transformations go. My amplitude is a. The period I can get from, the k value I can get from the period. Remember, k is going to equal 360 divided by the period, divided by 10. So my k value is going to be 36. I have to decide whether I want sine or cos. Remember, sine looks like this. Cos looks like this. These are rough, very rough sketches, of course. But cos starts at the maximum, whereas sine starts at the axis of the curve. This graph, clearly, if I look at the y-axis, is starting at the maximum. I would go with cosine. I can write this equation in terms of sine, but then I'd have to involve a horizontal shift, which just makes things a little bit trickier. Not that big a deal, but it's a bit trickier. Let's keep it simple and stick with cosine. So putting it together, I want to use cosine. So I'll start by just writing cos down here. And then I'll plug in things where they belong. So y or f at x, doesn't matter which I put in. Remember, a was equal to 2, so y equals 2. Cos, I had a k value, which was 36, and that goes in front of the x. There's no d value, because if I start with cosine, I don't have to do a horizontal shift. So I already mentioned that, but let's be specific and say d equals 0, because it's cos. And then I just have to add my c value in, which was 1. And here is an equation that represents this exact situation. Now I can use that equation to answer questions like E part. What's the height of the nail at 17 seconds? I suppose I could have done, again, I default to x and y. But in terms of this graph, it's height versus time. So maybe I should, stick to those. So I'm going to replace x and y with h at t and t so that I'm consistent with the variables. So clearly t is 17 seconds in this case, so I'm going to find h at 17, and literally I just put 17 into the function and work it out. So I'm going to follow order of operations. I have to find out what 36 times 17 is first, and then take the cos of that, and then multiply it by 2, and then add 1. I can just type that in my calculator all at once because it will do it for me, but I do have to, that does have to be taken care of. So 2 times cosine 36 times 17. See, that's inside the brackets, making sure that that order of operations is maintained. And then the plus 1 comes at the end. And I got 0.4. That's rounded to the nearest, what is it, meters? Yeah, I think it's in meters. It doesn't tell us the units. Oh yeah, there it is, centimeters on the axis. So 0.4 centimeters. So in other words, at 17 seconds, which I can even find on the graph, that's going to be somewhere around 17 seconds is going to be somewhere around here, right? Just a little bit before. That would be that line, 17.5. So 17 seconds is there. The height is 0.4 back over here. So it matches up with what's on the graph, as well it should, of course. But we can get the exact value from the function. A group of students is tracking their friend Jamal, who is riding a Ferris wheel. They know that Jamal reaches the maximum height of 11 meters at 10 seconds, and then reaches the minimum height of 1 meter at 55 seconds. Sketch the graph to represent Jamal's height as he rides the Ferris wheel. All right, so let's see. Let's draw a sketch like this. All right, so I'll just put my own markings on here. We know that the maximum height is 11 meters. So I'll just say that that's 11 here. And it occurs at 10 seconds. So I will arbitrarily say that this is 10 seconds here. So we know that he is at this height. Oh, here's an ordered pair. Let's put it that way. So 11 meters at 10 seconds. Then we have this other ordered pair, 1 meter at 55 seconds. We know that's the minimum. So if 1 meter, I assume, or I can say will be that high, 55 seconds is going to be, just judging with a scale I've estimated would be about here. We've got another point here. That's the minimum. That's enough to know what's going on. The fact that we know he's riding a Ferris wheel means he's going around in a circle, like the water wheel, which means it's going to be very periodic and sine or cosine like. So what's got to happen as far as time goes versus height, this would be height on the vertical axis, time on the horizontal axis. The graph is going to go from the maximum height, obviously, down to the minimum height. What we know about periodic functions, we know that if we go from the maximum to the minimum, that's got to be half a cycle. In other words, to get one full cycle in, he's going to have to get back to the top again, isn't he? So back to the top is going to be after some further time. And we know that the height is going to be 11 meters when he gets back to the top. We even know how long it should take him to get back to the top. It took him 45 seconds to get from 10 seconds to 55, so it should take him another 45 seconds to get back up to the top. So if I add 45 to 55, then I should be back at the top again after 100 seconds. And now we can see what one full cycle is going to look like. And I can get all the information that I need to write the equation. So from looking at this graph, Again, I could do it a couple ways. I could get the axis of the curve by using the formula max plus min divided by 2. Or I could sort of mentally do it as well, right? Just looking at this, halfway between 1 and 11 has got to be a value of 6. That's going to be my axis of the curve. So my C value is going to be 6, the vertical shift. What else do I need? Well, I need the period. So from this, the length of one cycle goes from 10 to 100. I can measure a cycle wherever I want. I just have to get the length of it. So if one cycle takes from 10 seconds to 100 seconds, the period has to be 90 seconds, doesn't it? So the period is 90 seconds. And that helps me because I use that to calculate my K value. K is going to equal 4. So there is another thing that I can plug in. What else do I need? Well, the amplitude. Remember, the amplitude is the max minus the min divided by 2. Mentally, 11 minus 1 is 10, divided by 2 is 5. Or I could measure it on the graph again. The distance from the axis, which is 6, to the max or the min is 5. So I could get it that way. Remember, amplitude's always considered to be a positive number. We don't worry about whether we're measuring up or down, so I'll just say it's 5. And finally, I do need to know, I need to know whether I'm using sine or cosine, and I need to know what shift there is based on that. So looking at this graph again and thinking, what does it look most like? If I imagine starting on the y-axis, or the h-axis in this case, then the closest thing would be the cosine curve, because it starts, at least what I've drawn, starts at the maximum at the top. And if I was just to backtrack this a little bit, it would look exactly like a cosine curve. It certainly looks more like a cosine curve to me than a sine curve. So I'm going to go with cosine. And as far as cosine normally starts at the right on the axis of the curve, this particular one must have been shifted over by 10 seconds, right? Normally, cosine would have a d value of 0 for one starting on the axis. So d has to equal 10 in this case. That's the last missing variable to put in to get my equation. So putting it together, h at t equals a, which is 5, cos k, which is 4, bracket t minus d, which is 10, and brackets plus c. So it all fits together really nicely. And you just have to get those 4 points. And once you got them, then you start plugging things in. So what was Jamal's height at 78 seconds? Well, that's my t value, isn't it? T equals 78. So h at 78 equals 5 times the cos of 4 times 78 minus 10 plus 6. And again, my calculator can take care of order of operations for this for me. If I was to estimate what I think it's going to be, 78 has got to be somewhere about halfway in between the 55 and the 100, doesn't it? It's not going to be exactly 6 meters, but I think it's going to be pretty close to 6 meters. That's my best guess. So let's see what the actual equation tells me. So I had 5 times cos, and then I had 4, and then bracket, 78 minus 10. Let's type it all in. I know I can do some of this myself in my head, but I want to just let the calculator take care of everything for me. So 4 times 78 minus 10, end brackets, and then I had the plus 6. And I got 6.2, let's say. So my estimate was not too bad because it was an educated guess, right? I looked at the graph. It wasn't a perfect graph, but I was able to estimate where we were again based on the fact that 78 would be about halfway between the minimum and the maximum. And so, yeah, I was able to estimate by the fact that it's very symmetrical and periodical, periodic, that it's going to be right in the middle. So when we're doing these kinds of functions, we want to identify the 4 transformations based on the graph. And if we don't have a graph, we want to draw it for ourselves.